How's everybody doing? Can you hear me okay?
Yes, we can hear you.
All right, very good.
Yes.
We've got several minutes before class starts, but if there are any questions, I'd be happy to take them. Still a couple of minutes before class starts, but are there any questions anybody has on anything?
Professor, do we allow to see our test result
We'll-
After,
We will cover the test on the 18th, next Monday. Make sure that everybody gets their test in and graded. The grades are out there. We'll actually go over the test question by question on Monday. There's just 10 questions, and we can get through those while we're going through our regular. I'll do 1.4, 1.5 in the test on Monday.
okay, awesome. Thank you.
And remember, your grades are out there, so you know what your grades are.
Yeah, I saw it. Thank you.
Sure. Okay, my clock shows 3 o'clock. Let's go ahead and get started on time. Today we'll cover sections 1.1, 1.2, 1.3. And then we'll cover 1.4, 1.5 in the test on Monday, 6, 7, 8 on Tuesday. Okay, so the plan today, we're going to cover 3 sections. So let me find, tell me I don't have my section out. I've got one. Go right ahead. Did I hear a question? Let me get out 1.1 here, make sure we cover what we need to cover. We haven't covered 1.1 yet, have we?
No, we have not.
Okay.
No.
All right. So in 1.1, we'll cover graphs and graphing utilities. And this may be review for some of you. If it is, feel free to either ask questions or tune out. Remember these, I don't take any attendance. So if you feel like this is not worth your time, feel free to go away. And this is not required at all. You're not gaining or losing points by being in attendance. So if we're graphing, using our graphing calculator and graphing utilities, what are we trying to do? We want to be able to plot points in the rectangular coordinate system, and we'll discuss that. Graphing equations, interpreting information about graphing utilities viewing window or viewing rectangle. And we'll take a look at the table. We'll use graphs to determine intercepts of the X and Y axis, and we'll interpret information given by those graphs. Now, if I were to give you, let me see here, let me bring up a piece of paper. If I were to give you, let me see here, something that looks like this, and I'm going to call the horizontal axis X and the vertical axis Y, and these meet at 90 degrees, and I'm going to call that location 0, both X and Y. That's the grid we're going to be working with. And going to the right, we're going to call that positive, and going to the left, we're going to call that negative. Going vertically upward, we're going to call that positive, and vertically downward, we're going to call that negative. So if I give you an ordered pair, say a pair X and Y, then that represents values in the XY coordinate plane. So if I gave you -2 and 4, for instance, you'd say, well, let's see, -1, -2, and 1, 2, 3, 4. And I could say, well, on this coordinate plane that has those hash marks, that would be the location -2 and 4. And that would be in what we're going to call a second quartile. We label our quartiles 1, which is this quartile, 2, which is this quartile, 3, which is this quartile, and 4. Okay, so we've got 4 quartiles that we're going to put values, that we can put values in. And if I were to give you, 0, -3, that says go 0 in the X direction and -3 in the Y direction, 2, 3. So we would end up down here, wouldn't we? 0, -3. Okay, if we're looking at the relationship between two variables. I might have a relationship, for instance, it looks like y equals, and I'll say y is equal to some function of x, and that function is defined as maybe 4 minus x squared. And so if I were to put in values in my, what I'm going to call a table of values, and I'll say TOV for table of values, and if I listed x on the horizontal axis and y below it, and maybe I list from -3, x is -3, -2, -1, 0, 1, 2, 3. So here I might be asking to plot the points for the function y equals 4 minus x squared, and plot those points from x goes from -3 to x equals +3. So if I'm looking at these, can I tell which is the independent and which is the dependent variable? Anyone?
I think the x is independent.
So we have independent and the y is dependent. Meaning that we put an input value for x and we generate a value from the function and supply that value as the y value. So in this case, if I provide an input value of -2 into this function, or -3, then I can evaluate y, and I could say, well, y is defined as 4 minus x squared. And if I put in a -3 and a 4 and square it, I'll have 4 minus 3 squared is 4 minus 3 squared is 9. 4 minus 9 is -5, isn't it? So at this point, I would say then what looks like at -3, y is going to be -5. Everybody agree with that?
Yes.
Okay, if I put in a 0 for x, then we're going to have y is 4. And if I put in a 3, because we're squaring it, 4 minus 3 squared is 9, that's going to give me -5 again, isn't it? So if I were to plot that on this xy coordinate plane here, x goes from -3, -1, -2, -3, +1, 2, 3. So when x was 0, we had 4, 1, 2, 3, 4. So here's 0 and 4. 3 was -5, 1, 2, 3, -1, 2, 3, 4, 5. So it looks like we're going to be down in here. That's it. 3, -5, and -3, -5. That's going to be down here as well. -3, -5. And so I've got 1, 2, 3. But if I were to connect these points, it looks like I'd have a straight line. But we're going to have to plot some more points because we know that this isn't a straight line, don't we? This is going to be a parabola because this x has an exponent of 2. It's x squared. So let's plot -2. So 4 minus -2 squared, that's going to be 4. 4 minus 4 is going to be what? 0. So at -2, we're here at 0. And aren't we going to be the same at +2? Okay, so we'll put points here. And so I'll say 0 and 0, and -1 is just 1. So 4 minus 1 looks like that's going to get a 3 and a 3 on the other side. So -1 will go up 1, 2, 3. So we'll go to approximately here, -1 and 3. And over here, we're +1 and 3. That's about there. Now I've got a little better set of points that I can plot. So the first thing I'm going to do in this situation is plot the points, and I go from left to right. So I'm going -3, -5. So that's this point, -2 and 0, -2 and 0. So that would be this point, wouldn't it? -2, 0. Here's -2 and 0. -1 and 3 is this point. 0 and 4 is this point. 1 and 3. 2 and 0. And I'll label. And what I'm doing, you'll notice, is labeling these points. And when you draw your graphs for me, I'd like you to label your points as well so that I know what the point is you're looking at here when you draw this curve. So now I can draw my curve that sort of comes down like this on the one side and sort of goes like this on the other side. Okay, and we have then a curve that looks like it's a parabola opening downward, and it continues as far as we want to go in the X direction and the Y direction. The maximum value we have in the Y direction is 4. The minimum value would be as far as we want to go, wouldn't it? There's no limit on however we want to go. Similarly for -x and +x. So if I look at this curve then and say 4 minus x squared is the curve, if I want to plot it from specific x values, say -3 to +3, I can do that in my table of values. And then I would plot the points. And then I would connect the points with a smooth curve. Okay, and I would get something that looks like that. Okay, so when we're working with graphs and graphing utilities, and I haven't brought out the calculator yet for any graphing utilities, and we'll do that in a bit. But before I go any further, everybody was able to get your calculator and you have your equipment so that you're able to get through the problems in class because you're able to use your calculators. The recommended calculator is the TI-84, is the one I'll be using for any demonstrations for the class, and that looks like that. If you're going to go on to take further math courses here at the college, 142, 151, 152, 153, and so forth, you probably want to invest in a calculator that looks something like that, or it has the equivalent function. There are other brands, there's Casio and so forth, but whatever you do, make sure that you have a calculator that is recommended by the course. Okay, questions on anything we've covered so far? Okay, let's take another example. Let's say that I want to graph something that looks like this. Y equals, and I put a vertical bar, and I put X and another vertical bar. And that really is the same as saying Y equals the absolute value of X. Okay, so either one of these represents the same thing. We could say Y equals some function of X, and the function is the absolute value. And the indicator that this is a function indicates by this left and right parenthesis here. ABS left right parent indicates this ABS function takes as input the X value and generates as output whatever the Y value is going to be. And then I can put in whatever values I want for X and see what gets generated. So again, if I do this and create a table of values where Y equals absolute value of X, and I might try it through some different values, maybe -2, -1, 0, 1, 2. So if X is 0, and I'm looking at the absolute value of 0, what would I put here?
0.
0, that's correct. Because anytime we're looking at the absolute value, really what we're doing is looking at the magnitude of the value that we're looking at. Here we have a -2 and a -1, but the negative really just indicates a direction on the real number line, doesn't it? If I have the real number line here, and it extends infinitely to the right and to the left, and this is a positive negative direction, and I arbitrarily pick some point and call it 0, then if I put some hash marks out here, 1, 2, -1, -2, then I could say, well, -2 is out in here, +2 is over in here on the real number line. So this absolute value says I'm not concerned with direction. I'm only concerned with magnitude. So magnitude here is 2, magnitude here is still 2. So if I say what's the absolute value of -2, it's still going to be 2. What's the absolute value of +2? 2. 1 is 1, -1 is still 1. So now I plot the points. And if I'm plotting them on my XY coordinate plane, here's X, here's Y. I'll just put some hash marks out here. We'll assume those hash marks are equally spaced. And we'll go to 4 and 4 and -4 and -4. So if I plot -2 and +2, I'm going to go here to -2 and +2. I'm going to say I have a point here, -2 and 2. The next point is -1 and 1. So -1 and 1 would be here, 0 and 0, 1 and 1, and 2 and 2. So if I connect those points there and there, then it looks like what I have is lines that go in that direction, and these are straight lines, and you'll notice that all the values are positive. Now, when you're doing something like this, what I want you to be sure you do is label each of these points so I know where they are. It isn't good enough to draw a line here and draw a line here and say that's where the point is, because if we're getting into decimals, particularly or fractions, we may not know exactly where that is unless you tell me. So you tell me that's at 2, 2, and this is at 1, 1, and this is at 0, 0, this is at -1 and 1, and this is -2 and 2. And if I were to label those on -2, -1 and 1, 2, 2, 0, 0, and here are the points here. Okay. And just to make it clear, I could color the line itself. You don't have to do that, but just to make it clear for you to see, I will do that. Okay, so now we're using the point plot method, and I guess I would just say point plot to plot the points. Then we connect the points, and then we draw the smooth curve, just like we did above. Okay, is that making sense to everybody, what we're talking about there? Now, you might be using your calculator to graph some of these, and in your calculator, it has something called a viewing window. And that's going to tell me, let's say I've got a XY coordinate plane, and maybe I go 1, 2, 3, -3, +3, and maybe I go down, I don't know, 5, 10, -10, and here's up 5, 10, maybe I go up 15. So these values here are 5, 10, 15, -5, -10. And I might have a viewing window that goes from -3 to +3 and -10 in the Y direction to +10 or +15. So my viewing window then is shown here. And on my calculator, that's what you're going to see. And you'll be able to specify what you want these increments to be. If you want the increments to be 5, you'll see just 3 hash marks, 5, 10, 15, and down here 2 hash marks in the Y direction. And I can specify different values for the X direction. I might want my hash marks to be 1, 1, 2, 3, -1, -2, -3. Okay, so on my calculator, I specify X and Y, excuse me, the minimum value of X and the maximum value of X. It looks as X min and X max. And we'll set this to, in this case, -3 and +3. And then it'll have a delta X, which the calculator calls the step, which you could call the interval. So I might want the interval in the Y direction different than the interval in the X direction. Maybe the X direction is 1/2 or 0.5. And in the Y direction, I might want it Y, maybe the minimum is down here at -10, and Y max is up here at 15, and the delta Y, or the interval, maybe that would be 5. You could set it at 1 if you wanted to. You could set it at 3. Any evenly divisible number will give you a nice line here. Okay, so we're able to set our calculator to show this kind of a window. Everybody familiar with that, or any questions on how to do
Could you
that?
go over the triangles, the triangle X and Y, as well as the interval again?
Yes, I will. In fact, let me just bring out my calculator here. And we were looking at, let's see, the first equation we looked at was Y equals, what did I say? So I'm going to go here. I'm going to hit the Y value. Let me clear up this, make sure you can see that, get this out of the glare here. So I'm going to hit the Y button, and I'm going to put in the equation that I used initially, which is 4 minus X squared. So here's 4 minus, and then I'll select X and square it. So there's where I enter my value for Y equals whatever I want the function to be. Then I'll hit the window button, and I'll hit window. And you'll notice it has X min, X max, and X scale. Okay, so that X scale is how we're going to scale between -2 and 4. So instead of calling this step, I'm going to call that what the calculator calls it, SCL for scale. Okay, so, and similarly for Y min, Y max, and scale. Okay, so if I set my window to match what I have on my paper here, I'd set X is -3. Now, keep in mind that when I hit negative, that was this value. This is negative, that's minus. These are not the same. Okay, so if I want -3, because I want to go X -3, that's here, and X to +3, I'll just step down with this arrow here, and the scale I can have as 1. And then Y minimum, I want maybe -10, and I'll step down maximum, maybe I'll say 15, and here it has scale as 1, and I'm going to change that to 5. So now when I hit graph, I get a graph of what that function looks like, and it's shown here. And because we have Y equals 4 minus X squared, and we plotted some of those points, when X is 0, it's 4. And I notice here that, get this out of the glare, that doesn't appear very well, does it? It's somewhere below 5. So maybe I want to change my window then by selecting window and saying, the Y scale, I don't want that to be 5. I want that to be 1. Now let's try that again. So I'll hit graph, and now I've got 1, 2, 3, 4. And I'm saying, well, that's fine. I can see it, but I'd like to zoom in a little bit. And I notice that the maximum that y goes to is 4. So maybe I'll set my window at +5, and it's just a downward parabola. So maybe I'll set it at -5. So I'll go back to my window, and I'll say, I want just -5, and I'll delete that 0, and max is just +5. Now let's try it again. Now that looks a little more what I want it to look like. It goes from x -3, x +3, y +5, y -5. So within that, I've got a nice curve that looks sort of like that, and I brought this window down and up, and so that I could see what this function looks like a little closer. Okay. Questions on how we did that and how we changed the window size, how we entered the y value and so forth? We covered this in your Math 97, Math 98, and 99. Has that all been covered? You all clear on that?
Wait, so like by changing the scale, what do you do again? Like how does that affect the overall graph? I'm still a bit confused on that.
All right. You can see that the graph is a downward parabola.
Uh-huh.
And when I changed the window, what I did is I zoomed in on that. It allowed me to zoom in on that.
Oh, okay.
So for
So
instance,
scaling is going to zoom it in. Or
yes,
zoom it out.
yes. If I change this y value to something larger than 1, 2, 3, 4, 5, let's say I go to 10 on the upside, don't change the downside, just change the upside to a +10. That's all I've changed is y max is 10. Now when I graph it, I've got 5 extra values up here. I shifted that graph down, didn't I? And if I wanted to bring the graph in narrower, I could say, well, instead of x equals 3 as the max, maybe I'll set x equal to 6 in the left side and 6 on the right side. Now when I graph it, it looks like that. And the larger I make my x values, the narrower that graph is going to be. So it's just the idea of changing the size of the window that you're using to view the graph of the equation of whatever equation you're graphing. In this case, y equals 4 minus x squared. Okay. Questions?
I'm really sorry if this is an inconvenience, but could you briefly just like review like everything that you said, if that's okay?
Were you having trouble hearing me or breaking up or just want a clear understanding?
Just want a clear understanding.
Okay, fine. So what we're doing is talking about viewing window for our calculator. And the viewing window is determined by this button, this window button. So if I hit the window button, the calculator says, well, what do you want the viewing window size to be? From the minimum x, I'm going to say it's -6. Maximum x is +6. And the scale is 1. So the scale is going to be -6, -5, -4, -3, and so forth, up to +3, +4, +5, +6. So that's the x min to x max, and that's a scale. And if I were to look at that, I can hit the graph button and -1, 2, 3, 4, 5, 6. So that's the 6 on the minimum, and then the 1, 2, 3, 4, 5, 6 on the maximum. So that's where I've determined x max. And you might want to be narrowing that in. Maybe you say, hey, I don't really need to go over that far. I would just want to go to x -1, 2, 3, maybe -4, and out to +1, 2, 3, 4. Then I can hit my window button and go -4 to +4. And that's going to bring me in closer to that curve. So 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the right. And I still have all this extra space at the top, and I'm say, that doesn't show me anything. I'm going to remove, and I'm going to go down to y equals 1, 2, 3, 4, maybe y equals 5 as a max. So I hit my window button and I say, I want y not to be 10 as a max, but 5. So I hit the 5 button and then graph it and see what it looks like. How did that change? Okay, so I zoomed in and I got rid of that extra 5. And I might say, well, I've got a bunch of extra here at the bottom too. I only want to go to maybe down 3. So I'll go down to y minimum is, let's say, not -5. Let's say it's just -3. So I'll go down here to -3 and then hit graph. And now I've reduced the size of that window again, essentially zooming in on this curve. This curve, no matter what my window is still y equals 4 minus x squared. Because when x is 0, y is 4, and it's a parabola. Because if we take a look at this value here, given that it's squared, it's a parabola. Given that it's negative here, it's a parabola opening downward. And given this 4 here, that says, where is the parabola crossing the y-axis? So we can tell a lot by this curve before we ever graph it. We can look at this thing and say, we know it's a parabola. Well, parabolas generally look like that, don't they? But this is a negative opening. It's negative value. So it's going to be opening downward. So it's not going to look like this. It's going to look like this. And it's not going to start at the origin at x0, y0. It's going to start at y equals 4. 1, 2, 3, 4. So now that's going to shift this parabola up. So it's not going to be this line. It's going to be that line. So without ever graphing it, we could say, I know it's going to look something like that. And then I put it in the equation 4 minus x squared in my y value, and then look at my window, say I'm going to go from -4 to +4 in the x direction, -3 to +5 in the y direction, and then I'll graph it. So I'll hit the graph button and I get that, which is pretty much what I'm showing here. That clear up things for you?
Yes, please. Thank you so much.
Okay. All right.
I had
Uh,
a quick question.
Yes, go right ahead.
So I'm clicking on the graph button and I'm getting an empty graph. So I'm not sure why this is happening.
Well, is this what you had when you hit y1? Did you get that?
Yeah, I'm in the window and then I have the x min equals -6, for example. Is that right?
You can put -6. I can put -6. There's -6. What did you put for x max?
I put +6.
+6. That's fine. I'll put 6. And what do you have for an interval?
I have 1.
All right. And then y min?
I have -5.
-5. Okay. There's -5. And y max?
It's +5.
5. That's fine. And the scale?
It's 1.
All right. And when you hit the y equals button, what do you have for an equation?
Oh, I didn't have the y equals button. I think that's why.
Yes, you have to have an equation to plot. Otherwise, it won't show anything.
Okay.
So once you enter 4 minus x squared, then hit graph, then you should be able to see the graph in the viewing window that you've just given it.
Okay.
Any other questions?
Is there a way of the equations? Sorry.
I'm sorry, I missed that. Is there a way to what?
Is there a way to see, like, instead of counting which the x of the equation, like the answer,
Right.
is there a button that could give us
You
the
want to
answer?
see the actual value of the x-intercept?
Yes.
Okay. So if we do a second and calc, here's the second button and here's calc. And then I can say, well, what do I want to find? Well, if I want to find the intersect, I could go down to 5 and hit intersect. And then it's going to say first curve, second curve. Well, I only show one curve. So if I want to show the intersection of this curve, this downward opening parabola, and the x-axis, I'm going to have to enter that x-axis as a value in my y equals. So I'm going to go down to y2 equals and say y2 equals, what value would I put in for y2 if I wanted to be on the x-axis?
0.
0, right. So I'll say y2 equals 0. Now the calculator shows you a couple things, both the equations, y1 and y2, and it shows you the color, blue for y1 and red for y2. So that when I hit graph, see that red coming across there? So now I have two lines, this x-axis and this curve that represents the parabola. Now, if I want to find out where the parabola crosses the x-axis, I can hit my second and calculate, which is up here, and say, I want to find the intersection, which is 5. And the calculator comes back and says, which of these is your first curve? And I'm going to move this cursor down by hitting the right arrow here. And I'm going to say, that's my first curve, this blue one right there. And then I'm going to hit enter. And then it's going to say, which is your second curve? And the cursor is smart enough to say, hey, I see another line here. Is this your second curve? And I'm going to say, yes, it is. And I'm going to say enter. Then it's going to say, do you want me to guess where the intersection is? And I'm going to press enter and say yes. And the calculator does a calculation and says, here's the cursor showing the intersection. And the intersection is at x equals 2 and y equals 0. Okay, which we saw on our table of values, right? When we plotted this thing originally with our table of values, that's what we had, didn't we? Okay, questions?
So which button did you use for the intersection again?
Well, I went to second and calculate and went down to 5 intersect. Now, for what we're doing, I'm going to go through and show you that. But this course is not a TI-84 learn how to use your calculator course. This course requires that you, number one, have a calculator, and the one I'll use is TI-84, and you need to know how to use your calculator. So number one, make sure everybody has the calculator. And number two, if you need to learn how to use it, my recommendation is, because these things do lots and lots of stuff, I would recommend you go to the ti.com website, download the user's manual for this calculator, and you can get a free user's manual. If you want to buy one to have paper, you can get something like this that says, hey, here's a dummies book. You know, there's a whole collection of books that are called Something for Dummies, and they've got them for about anything you want. And so here's one for this calculator. Some of you might use a TI Inspire. There's one for that. There's all kinds of books that you can get for your calculators. And I would recommend that if you need to know how to use your calculator, that you go ahead and invest in either downloading the user's manual for the TI-84 or investing in a paper copy. Either way works fine. Okay, other questions? Okay. Let's say we have something that looks like the following. Say I give you an XY coordinate plane, and here's X, here's Y, and I have a graph of a line, and this graph, let's say it's 1, 2, and over here, -1, and here's 0. And I say, here's a line that looks like that. Here's a point here and a point here. And I ask you where that line intersects the x-axis. What would you say?
At 0, -1.
Okay, right. Not 0, -1 would put me down here, wouldn't it? Because 0, -1 would look like X and Y.
Yeah. -1, 0.
-1 and 0 is what we want for this point here. So this point is -1 and 0, and I'll label it. And how about this y-intercept? What's that point called? New volunteer.
0, -2.
0, 2.
0, 2, not -2, 0, 2. Right. So 0, 2, 0, 2 is located here.
0
Is located
or
there.
0, 2.
Okay, be sure you turn off.
Zero.
Be sure you turn off your microphone after you've given your solution, please. All right. So now we have where this line, and I'm going to say this is a line, and I'm going to tell you it's a line. It's not any kind of a curve. I suppose it could be a curve, but I'm going to tell you it's a line, and I'm going to tell you that a line has the general form of the equation of a line is what? Anybody know the general form of the equation of a straight line?
mx plus b.
Mx plus b, where m represents
Slope.
slope of the line, and b represents
The y-intercept.
y-intercept. Okay, so here's the general equation of the line. Now I give you two specific points, -1, 0, and 0 and 2. And now I ask you, what's the equation of this line that I gave you? I'll put it in blue here. That's a straight line, and I've given you 2 points on that line, and I'd like you to give me the equation of that line. Do you have enough information to do that?
Yes.
Okay.
I think the line is 2x plus negative. I mean negative subtracted by 1.
So you want y equals 2x minus 1 like that?
Yes.
Okay. Anybody else? Thank you for volunteering. Anybody else volunteer? Now, I've been given an answer. I don't know if that's the correct answer or not, but I've been given an answer. What I would prefer you to do is tell me how I know for sure what the equation of that line is. Knowing that y equals mx plus b, what's the slope of this line? And more importantly, how do I determine the slope of that line? So if the slope of the line is m, how do I determine the slope of that line?
Is it something like, I don't know about if it's, I'm not remember the whole thing. Is it like y2 minus y1 over x2 minus x1?
2
And
minus
and for those points you use
x2
-1,
minus
0,
x1.
and
All
yeah.
right. So that's fine. That looks
That's
like that
mixed
might
it,
work
yeah.
for M. How about for B? New volunteer. How do I find B? What's that?
That's the y-intercept, so that
That's-
would be 2.
B would be 2, the y-intercept. Okay. Now, given that information, am I able to develop the equation of this line? Well, let's just plug in some values. M equals, now we have a y2 and a y1. What do we want to use for y2 and what do we want to use for y1? Well, you can use whatever you want. I normally go left to right, and I take the leftmost point and I call that point 1, and I call that x1, y1. And I go over here and call that point 2, and I call that x2, y2. That isn't mandatory, but it's what I use. So in this case, y2 is going to be the y value up here, which is 2, minus y1, which is the y value down here, which is 0, divided by x2, which is the x value up here, that's 0, minus x1, which is -1. So that should be the equation for the slope. So that says it's 2 divided by negative times a negative. That's a positive, isn't it? So that's over 1, or m is 2. So if m is 2 and b is 2, then it looks like the equation of the line is going to be y equals m 2 times x plus b, which is also 2. So if this were a test question, I would expect you to show your work like this, show your answer like that, and you'll notice that that does not match what we had here. Okay, that was not a correct answer. And that's okay. We really didn't have any work showing us that answer. We might have just said, well, let's see, the slope looks like it's 2, and I have an intercept of -1. That looks like what somebody might have done to come up with that answer. But the equations that we use are different than that, aren't they? The equations say, here's how we determine slope, and here's how we determine intercept. And so then I can put my equation in the form y equals mx plus b, and it looks like that. Okay, questions on what we've covered there at all? Okay, I'm going to keep going. Let's say I have x, y, and I have some points that look like this on my table of values. And I say in my table of values, I have some x values and some y values. And maybe 1, 2, 3, 1, 2, 3, and so forth. And I come along and I say, well, when x is 2, y is 0. And when when y is 1, x is 2. And when y is 3, x is still 2. So I plot these points and I say 2 and 0, that's this point. 2 and 1, that's the point right above it. And 2 and 3 is up here. So here's 2 and 3, 2 and 1, 2 and 0. Those are my 3 points. And I draw a line through those 3 points. And I say, that's the line through those 3 points. So everything's good so far. And then I say, okay, this is a straight line. So the equation of a straight line, y equals mx plus b. So the test question says, or the homework question says, find the equation of this line. What is the equation of that line? What am I going to do? I don't want somebody to say the equation of that line is blah, blah. I want somebody to say the way we determine what that equation is the following.
So we can find the y-intercept. I believe that's 0 because it's not gonna ever touch the y-axis. So we can plug in b as 0.
Okay, b is 0. Okay, b equals 0. Okay. What's the slope of this vertical line?
Well, if we want to use the equation we were using earlier where m equals y2 minus y1 over x2 minus x1, and we can plug in values for that and find out that the slope is just 1.
Slope is 1.
I think the slope is undefined because
Actually, yeah, thank you.
Because
I have a slope.
y2 minus y1. So
Divide by 0.
Okay, we can't be dividing by 0. So we're going to say that this slope is undefined, isn't it? Okay, so we know the slope is undefined because we can't divide by 0. And the x values are the same. 2 minus 2 is 0. So the slope is undefined. The y-intercept is 0. And that's fine. Everybody agrees. So the question is, what's the equation of that line? Just highlight it like that. Or do we not have enough information to say what the equation of that line is? Or maybe we don't, maybe we can't give an equation of that line. Maybe a vertical line with a slope that's undefined that can't have an equation. What do we think is going on here?
Well, the equation for the line itself should just be x equals 2 because it will constantly give a value for 2 whenever you try to find x.
Okay, so for all values of y, x is 2.
Right.
All right. So that's how we're going to determine this line is no matter what y is, x is 2, whether y is positive, very large number, or 1 or 0 or -3 or negative very large, doesn't make a difference. X is always 2. Okay, it's independent. But if I have a line that goes that way, that pink line, is there a way to determine the equation of that line? Horizontal line. New volunteer? Let's have everybody give a chance.
You would
Go ahead, somebody help me out. Nobody's going to help me? Nobody knows, nobody cares, what?
I think the slope will be 0 because
Okay, all right,
using the
m
equation.
m equals 0. Okay, I would agree with that. So what's the equation of that line?
Y-intercept is 0, 3, so you can make B 3 for that.
B equals 3. Okay. So what's the equation of the line?
it would be y equals 3.
Y equals 3. And we get there by saying, well, y equals mx plus b. M is 0, so that goes to 0, and that was 3. So y equals 3. Okay, good. All right. That's all I plan on covering for section 1.1 on graphs and utilities. Okay, so we should have covered everything you need to know and everything you ever wanted to know on graphs and utilities. So I'm going to put that away and go to the next section, which is 1.2, which is basics of functions and their graphs. And the kinds of things we want to determine are, we want to be able to find the domain and range of a relation, and we can call that relation a function if we want to. Determine whether a relation is a function. Determine whether an equation represents a function. Evaluate the function, maybe at various locations. Graph the function by plotting points. We've done some of that. Use the vertical line test. We haven't talked about that yet. We've graphed function by plotting points, but we need to find out what a vertical line test does for us. Obtain information about a function from its graph. Identify domain and range of a function, and identify intercepts. Okay, so those are the kinds of things we want to do in section 1.2. So if I gave you some points here, let's say I give you these points. 0, 9.1, and 20 and 10.7, and 40 and 21.2, and I'll just pick a couple more points. 10 and 6.7, and let's say 30 and 13.2. Just pick some random numbers here. And I'm saying this is a relation between x values and y values. Okay, so each of these represents x value and a y value. And it's this relation that we're talking about. Now, if I ask you to give me the domain of this relation. Could you do that for me? Do we know what the domain of that relation would be? And what do we mean by domain? How would I even know what the domain means if I'm asking for these points? If I plot those points, I guess I could plot 0. Let's see, I'm going 0 through 40, 0, 10, 20, 30, 40. And I go up to 21. So let's say that's 20. And there's 10, and there's 5, and there's 15. So here's X, and here's Y, and here's 0. 0 and 9, 1. I'm going to say that's right here. 20, 10, 20, 30, 40. Actually, I think what I'm going to do is make some grid lines here so I can do it a little bit better since I don't have any graph paper that I'm using. So let's see, 10 and 6.7. So 10 and 5, so that's about there. And 20 and 10.7, so that's maybe here. And 30 and 13, maybe that's there. And 40 and 21, maybe that's there. Maybe I've got something that does this. Okay, these are supposed to be straight lines there. So I've got some relationship here between Y values and X values. And I ask you for the domain of this relation between X and Y values. Do we know what domain is?
Is it the distance covered by the X?
It's the values in the X direction. So I'm looking at values, and let me just highlight them here. So I'm just looking at these X
That would
values.
be, would it be
0.
0 to 40?
Well, it would be all the values. So the domain would be 0, 10, 20, 30, 40. 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the domain then would be all of these values. Okay, and I'll just say the domain is the set of values from 0, 10, 20, 30, 40. Okay, that makes sense to everybody what we're talking about there? Okay, how about range? Anybody ever heard of range in relation to these math concepts we're talking about? The range represents the Y values. And I'll just highlight those in blue. So the set of range values then, so for 0, we had 9.1. And for 10, we had 6.7. For 20, we had 10.7. For 30, we had 13.2. And for 40, we had 21.2. And I'll enclose those sets with these braces. So when we have that set of values in that relationship between X and Y points, then I'm saying here's my domain and here's my range. And the domain represents all the X values and the range represents all the Y values. Okay. Now, when we're talking about functions, we need to define what a function is. And for a function, we're saying that a function represents a relationship between a set of values that represent X values and a set of values that represents Y values. And for a relation to be a function, there has to be just one X value that represents a Y value. If an X value represents more than one value, y value, it's not a function. So each x corresponds to a unique y value. So if I have an x value here, there's a y value here. If that's x1, that's y1. If this is x2, then that corresponds to a single value over here, y2. And if I have an xn over here, then that corresponds to a yn over here, whatever the number is. So it's a unique value. We don't have any one value here providing two values here. That's how we're going to define a function. Okay, questions on that at all? Okay. Before I start a new example, I have awfully close to 4 o'clock. Now I have 4 o'clock. So let's go ahead and take our break. Let me put a little note out here. We want a 5 or a 10-minute break. How much do you need?
5 minutes.
5 minutes? Does that work for everybody? If we take just a 5-minute break, we'll end 5 minutes early, if that makes a difference. If we take a 10-minute break, we'll get out at 5:10, if that makes a difference. Okay, so we'll see you back here at 4:05. Good work, everybody. No questions? Okay. Well, we'll continue then through some more examples. Let's say I give you this set of values and I say, is this relationship a function? And I give you some points. And I say, there's a set of points. And I say, is this relationship a function? And before you say yes or no, we want to know how we determine whether a relationship is a function or not. So remember we said we have a set of X values and we have a set of Y values. And we determined that for each X value, there's just one Y value. So looking at that, can we plot those points and make a determination whether this relationship is a function?
Yes.
Yes, it is.
Yes.
Okay, so let's go ahead and plot the points and make sure. So we have 1, X is 1, Y is 2. So here's 1 and Y is 2. Here's X is 3 and Y is 4. That's good. X is 5 and Y is 6. That's good. And X is 5 and Y is 8.
So it's not a function.
So it's not a function, is it?
No.
Now, if we were to plot these points to see if we can tell graphically, let's see, 1 and 2, we have a point here. 3 and 4, so we have a point here. 5, 2, 3, 4, 5, 6. 5 and 6 is here. 7, 8, and 5 and 8 is up here. So we have a set of points that when we connect them at X equals 5, if we go more here to 5, we say, well, it could equal this value, 5 and 6, or it could equal this value, 5 and 8. Now that's fine if we have data that does that, but it does not represent a function. Okay, so this relationship is not a function because 1x ends up at 2y's. Everybody clear on what we're doing there? Okay, how about if I give you another set? What if I give you 1 and 2, 3 and 4, 6 and 5, 8 and 5? Does that represent a function?
No, because you get the same Y value twice.
Okay, so if we were to plot that, what would that look like? So 1 and 2, 1 and 2, 2, that's here. 3 and 4, 1, 2, 3, 4, 5, 6, 7, 8. And in the Y direction, we go up to 5. 1, 2, 3, 4, 5. So 1 and 2, 3 and 4 is here. 6 and 5, that's here. And 8 and 5, that's here. It looks like it might sort of go like that. Everybody agree?
That's what the graph should look like, yes.
Approximately. I mean, it's, rough, but 8 and 5 and so forth. And I'd want you guys to label your points 1 and 2 and 3 and 4 and 6 and 5 and 8 and 5. So again, did we think this is a function or not a function?
I do not believe it is a function because of the same reason that we gave for the last graph where we got two values or an x being two y values. In this case, it's a y being two x values. So I don't believe it's a function under the same circumstances.
Well, we said that an x couldn't be two y values. Did we say anything about a y not being two x values?
No, I'm assuming that. So is that not the case?
That's not the case. That's
Okay.
correct.
So then this is a function.
Yes, because this is our independent variable and y is the dependent variable. So this is dependent, independent. We can't have an independent variable pointing to two different locations. And we don't have that here. Our independent variables are 1, 3, 6, 8. 1, 3, 6, and 8, and they all end up at different values. And that could be legitimate data, and we could draw that curve showing that. So does that make sense to everybody? Is that clear to everybody?
Yes.
Okay. All right.
So only y values, you can count those as functions. Is that the case?
What we're saying is that yes, a unique x value has to point to a unique y value, not the opposite.
Okay. Thank you.
Okay. All right, so we've used that page. Let's get another piece of paper here. Let's solve the equation and then determine whether it's a function. So I'm going to say solve for y, and then to determine if y is a function. Okay, so for the first one, let's say you're given 2x plus y equals 6. Can we solve that for y? And is y a function?
The answer is yes, it is a function. We're just going to move the 2x to the other side. So we'll just have a negative slope.
All right, so when we solve for y, we get y equals negative 2x plus 6. Okay, and is that a function?
I believe so.
And how do we know that?
We plug the values into a graph. We're not going to end up getting any dependent variable. We won't get multiple dependent variables for one independent variable.
Okay, everybody agree with that? Anybody disagree?
Agree.
Is there any shortcut how we can figure that out quickly?
Okay, if we were to create a table of values for x and for y, negative 2x plus 6, we could plug in some values here, couldn't we? We could plug in what? X is negative 2, 0, positive 2. If x is 0, we get a 6. If it's a positive 2, we get what? Positive 2. And if it's a negative 2, we get 4. So we get 10. So if we were to graph this thing, at x is 0 is 6, x is 2, it's 2, and x is negative 2, it's 10. So it looks like it's something that looks like that in general. And we can go as far as we want, but this looks like y equals mx plus b, doesn't it? And that's the equation of a line. And the equation of a line is a function, isn't it? Makes sense to everybody?
Thank you.
Okay.
Yes.
All right. What if we have, let's see, maybe something a little more interesting. What if I have x squared plus y squared equals 1? And is y a function? And more importantly, how do we determine whether it's a function or not? What do we say the process we used was 1, solve for y, and 2, determine if y is a function. So that is one unique input pointing to one unique output. So if we solve this for y, can you solve that for y? What does y look like when we solve for that?
So subtract x squared.
All right, very good. So y squared equals negative x squared plus 1. That's a good first step. Thank you.
And graph it.
Graph it.
Yep.
All right. So if I put, you want me to put a table of values?
Yes.
Okay, table of values, x, y. What values would you like me to use? We certainly can use 0. So if x is 0, what's y?
1.
Well, let's solve it. So this says y squared equals negative 0 squared plus 1, like that. So y squared equals 1.
Equation on top, I mean, the y squared equals.
Oh, okay. Yeah, we can do that. Y squared equals negative x squared plus 1. And you want to take the square root of each side?
Yes.
Okay, there's a square to the left side and there's a square to the right side. Okay.
And you'll get y equals the square root of negative x squared plus 1.
Like that?
Yeah.
Okay, everybody agree?
Could we simplify that even more, or is it not possible to get
So the radius squared equals this square plus this square.
Right. Sorry, I should have been more specific.
So x squared plus y squared equals r squared, or r equals the square root of x squared plus y squared. Okay, so when we see something that looks like this, we're looking at the equation of a circle. So if I look at something like this, I'm saying, well, I took this and I solved it for x. I solved it for y. So let's see if we can put that into our calculator. So let me get rid of what I had in there. And let's say I want to graph this equation. I want to graph this equation. And you say, well, you can't graph that equation because you would be graphing this thing. Well, then I come back and say, well, then let's graph two equations. Let's say y1 equals the positive root of negative x squared plus 1. And let's say y2 equals the negative root of negative x squared plus 1. We should be able to do that, shouldn't we? Let's see if we can. So let's say y1 equals the root of negative x squared plus 1. And let's say y2 equals, let's say it equals the root of, I want the negative root, sorry. The negative root of negative x squared plus 1. All right, so we want the root of that thing. So now I want to graph it from where to where. I need to set up a window. Well, I've got the default from the last time I did it. And if we're saying this has a radius of 1, maybe I go out just to -2 and +2. And similarly for y, -2 and +2. And let's hit graph and let's see what we get. Okay, so the blue represents the positive root, negative x squared plus 1, and the bottom, the red, represents the negative x squared root of negative x squared plus 1. Now this doesn't look too much like a circle, but if I increase the value of the x values, go back to my window and say, instead of doing -2, let's go -4, and let's see what that looks like, negative to +4, and see if that helps out. Well, that looks a little more like a circle. I could try 3, see if that looks a little better, from 3 to 3. So that looks sort of like a circle. And what we're finding then is, while we can't graph y equals plus or minus this thing, I can split that up into two equations. And I can call one equation y1 is the square root of negative x squared plus 1. And we're taking the positive root of that. And then the second one, we're taking the negative root of the same value. And when we graph that and we have our window set up so that we're -3, +3, then we end up looking pretty much like a circle. Okay, that makes sense to everybody? What's going on there? Questions on that at all?
Could you do like another problem like this?
Well, let me see here. I'm not going to do another one. I could move that circle around, but we'll, after class, if you want me to do more examples, I've got too many other things I want to cover. Keep that in mind and remind me at the end of class, and we'll do another one. The only thing we could change, for instance, might be the radius. We might say x squared plus y squared equals, oh, we could say 4, or we could say 6, or we could put any value we want in there. And I would invite you to do that while we're kind of working our way through and see what you get. Okay, so let me go on to make sure I can cover everything that I want to cover in section 1.2. So if I ask you to evaluate the following, And if I give you a y equals some function of x, and that function is defined as x squared minus 2x plus 7, for instance, and I say, find f evaluated at -5. Would you be able to do that? In other words, what does this mean? If I say f not of x, but of -5. Then that,
Substitute negative
yeah.
5 into the equation for x everywhere that it appears.
Yes, -2 times -5 and plus 7. Okay. So when I do that, what do I end up with? When I square the -5, what do I end up with?
25.
5.
25? Is this negative?
Positive 25.
So if I list it like this, I get positive 25?
Yes, negative, negative, positive.
Well, let's keep in mind order of operations. -5 squared. So I go left to right and I say I'm going to have a negative value of what? Of 5 to the second power, which is the higher order of operations, 5 to the second
The
or
exponent.
the exponent. So this says we have 5 and times 5 times 5. So that's -25 listed like that. So if I want to take -5 and square it, I have to put parenthesis around that and say it's -5 squared.
So, Professor, if you did that further into the equation, why didn't you do that before? I mean, I would have thought that that was assumed that you were going to put the parentheses like that in every spot that it appears.
If I say -x square, then order of operations says I do this first and I do this second.
So why are you, never mind.
You always do order of operations.
Yep.
Okay. So f evaluated at -5 equals -5, that quantity squared, minus 2 times x, which is -5, plus 7. So now we're going to get our 25, aren't we? Because this is a -5 quantity squared, not -5 squared. These things are not the same. So this -5 quantity squared is 25. Negative times a negative is a positive, so that's positive 10 and positive 7.
So when
25.
I'm describing how to set up this problem in the future, you want me to say substitute in the quantity of -5 everywhere an x appears. Is that correct?
Yes.
Okay,
Yes.
just making sure because I don't want to confuse the class with terminology. I assumed that you were going to do that the very first time I told you how to set up the equation.
Okay. So anytime we're doing
Now we know.
something, okay, so yeah, something like this, we're going to just substitute -5 for x. And when we do that, we get -5 squared. Okay, so that's what we're doing here, -5 squared. When we do that, then we say f evaluated at -5 is 42. And so that's how we're going to display our answer. And here's our work up above. Okay, let's try another one. Say I have y equals f evaluated at, well, let's make sure we bring down what we had earlier. We said y equals x squared minus 2x plus 7. And now I want to evaluate at x plus 4. Y equals, in this case, we're just saying y equals f of x equals this equation. Here we're saying y equals f of x plus 4 in this equation. And we want to decide what we get when we substitute x plus 4 into this equation. So go ahead and do that. And then we'll step through our answers and see if we agree on what we got. What did we get? Anybody? New volunteer? What did we substitute in here for x?
So
X
x
plus
plus 4 into 2x.
X plus 4. And we square that.
Right.
Minus 2. X plus 4. Plus 7. Okay. Everybody agree? So x plus 4 quantity square, what's that going to give me?
16.
X squared plus 8x plus 16.
Okay, we got that by saying x plus 4 times x plus 4. And we foiled it, didn't we? First, outer, inner, last. First times first is x squared. Outer is 4x, inner is 4x. We add those two together, we get 8x. Last is 4 times 4 is 16. Okay, so that's evaluates that. And then we distribute a -2 through this parenthesis. -2 times x, -2x, -2 times 4, -8, plus 7. Then we want to simplify, gather our terms. How many x squares? Well, looks like just one, huh? How many x's? We have 8 minus 2. So it looks like that's just 6 x's. And then we have constant, we have 16 plus 7, that's 23, minus 8, that's 15, isn't it? So when we evaluate this equation at x plus 4 and do the arithmetic here, we get y equals x squared plus 6x plus 15. Okay, everybody agree? Questions? Okay, let's try one more, and then we're going to go on to the next section. If I have f of x equals x squared minus 2x plus 7, and I evaluate it at -x, what am I going to get?
I got an answer.
Okay, go ahead.
I got 3x plus 7 because
3x plus 7.
yeah, because I plugged in -x for all of the x values. So I got -x parentheses squared
-x
and parentheses around it.
like this.
So the quantity of -x.
Yeah,
So you want -x like that.
yes.
Okay.
And then I multiply -2 by -x
2 -x. Okay.
plus 7.
Plus 7. Okay, good.
By simplifying it, I get x because -x squared is x minus 2 times minus x is plus 2x
Negative x, the quantity negative x squared is just x. Is that what you're saying?
Yeah. Oh, no, sorry. Is it would be x squared
X squared, okay.
and then plus 2x.
So this changes to plus 2x, okay,
Plus 7.
plus 7. So f evaluated at negative x is this. Everybody agree? Anybody disagree? Okay, so we want to be a little bit careful when we're doing substitutions. We substitute the entire value. Okay. Now just a couple of quick ones here. Have we talked about vertical line test? If we haven't, we'll talk about it right now. Vertical line test says we're going to run a vertical line over whatever function or curve we see. And let's put a few of them here. Let's say I have a curve that looks like this, and maybe a curve that looks like this, and maybe one that looks like this. Vertical line test is to identify whether this graph represents a function or not. And remember, we can only have one y value for every x value. So this first curve I'm looking at, does it pass the vertical line test to show that this is a function?
Yes.
So that is a function. How about one that looks like this?
No.
And then a new volunteer for this one?
No.
No. Okay, good. So if we're going to get two y values for any one x value, it's not a function, is it? That's how we're defining it. Okay, good. I'm now going to go on to the last section we're going to cover today, which is P.3. And in P.3, we're going to spend more time on functions and their graphs. And we're going to see if we can do the following: identify intervals on which the function increases or decreases or is constant. We're going to use graphs to locate relative maxima and minima, find out what those mean. Identify even or odd functions. We'll have to kind of define what we mean by even or odd functions. And piecewise functions, what are those? How are they defined? Okay, and then the difference quotient, what is that? How do we define it? So if I'm looking at examples, let me turn this around here. So if I have a function that say, let's say it does this and does this and does this, and here and here, here's an intercept and here's an intercept and here's an intercept for x and y, and maybe this function comes down and does that. And if I were to say, where is this function increasing and decreasing? Now let me simplify this a little bit. Let me just say, let's say it doesn't go back up. Let's just say this just goes down. Let's simplify it. Let's say it goes like this, and this keeps going up and goes like that, up to positive infinity, and this goes down to negative infinity, and here's x and y, here's our origin. Okay, and maybe this is at 0 and 2, and maybe this is at 2 and negative 2, this point here. So we can say that this graph of this curve is increasing from negative infinity until it gets up to, in the x values, negative infinity to 0, and then it turns down, and from 0 to, let's call that 2, it's going down, and then from 2 to the rest of positive x infinity, it continues up. And so if I say, where is this curve increasing? You're going to say, well, it's increasing all the way from here, negative infinity, but I don't include negative infinity, do I? So I say it's negative infinity, and this left paren says I'm not including the negative infinity, up to x is 0. So here's x is 0. And I don't include that 0 because at 0, a point would be, it'd have a slope of 0. Similar down here, we'd have a slope of 0. So we are increasing until we get to 0, but not including 0. So I'm going to call that increase. And then from 0 to 2, 0 to 2, I'm going to say it's decreasing. And I don't include that 0 because at 0, it's horizontal, slope of 0. And down here, same thing, so I don't include that too. And then I'm increasing again from 2 out to positive infinity, aren't I? Okay, does that make sense when we're looking at a slope increasing, constant or 0, and then decreasing? Questions on that at all? Okay, new concept now we haven't talked about before, and that's determining whether a function is a function even or odd. And how do we define an even and an odd function? Okay, if I find that, let's say I show the function here, and I have a function that goes like that, and here's x and y, and here's little x on my x coordinate plane, and here's y. So I'm going to call this point xy. Here's y here. And if I come over the other direction to negative x and positive y, I'm going to say this point here is located at negative x and positive y. And if I draw a line here, so now I've got a function that at x and y locates here. And here I've got a function that at negative x and y locates here. And so I'm going to define this by saying that if f evaluated at negative x, which is here, is equal to f evaluated at x. So f evaluated at x is this value here, y. F evaluated at negative x is the same value, y. If that's true, I'm going to call that an even function. If, on the other hand, f evaluated at negative x equals negative f evaluated at x, I'm going to call that odd. Let's see what that would look like. So if I extend this line down here and extend this line down here and say, here's negative x and negative y. Okay, so now this distance is the same as this distance. So then f evaluated at negative x equals negative f of x, and that's located here. So here's f evaluated at x. Here's f evaluated at negative x, and you'll notice that it's negative y. Then this is an odd function. This would be an even function. Okay, questions? That's the general rule. I'll take you through some actual examples, but I just wanted to make sure that we knew what the general rule was. Questions on the general rule? Okay, let's say I give you f of x equals x squared plus 6. And I say, is this function even or odd? How could we tell whether this function is even or odd? We could plug in a value, couldn't we? Okay, well, f at x, if x is, let x equal 2. All right, so f evaluated at 2 equals 2 squared plus 6. That's 4 plus 6 is 10. Okay, let's evaluate it at x, f at negative 2. That's the negative x value. So that's going to be negative 2 quantity squared, isn't it? Plus 6 equals negative 2 times negative 2 is 4 plus 6 is 10. Those are the same, aren't they? So if those values, f evaluated at 2 and f evaluated at negative 2 are the same, what are we calling this function, even or odd?
Even?
Even, correct. Okay, let's try another one. Let's say I have a function g of x that's 7x cubed minus x. And I want to determine whether that's even or odd. So the question would be, does g at negative x equal g evaluated at x? What do we think? Well, if I put negative x for x in my original function, I would say let's say g of negative x equals 7 times negative x cubed minus x. So what's negative x cubed?
Negative x cubed still. It just,
Okay, so it's going to be negative 7x cubed. Changes the sign, doesn't it?
yeah, it's still a
Okay.
negative.
Plus x. Okay, so when we substitute a negative x in here, cube it, we get a negative x cubed. So we get negative 7x cubed, and then put in a negative for x here, and we get a positive x. So the question we ask ourselves then, here's g of x, here's g of negative x, and the question is, are they the same?
No.
No, they're not, are they? So if g of negative x equals negative g of x, so does g of, so we said it's not even. It's not this. So now let's try g at negative x. So g at negative x, does that equal negative g of x? Because if it's this, what do we say? If f evaluated at negative x equals negative f of x, g negative x equals negative g of x. Is this true? Well, g of x is 7x cubed minus x. If we put a negative in there, we get this value, right? And the question is this value the negative this value, or is this value the negative of that value? If I multiply this by negative, what do I get?
You get the original value of 7x cubed minus x.
I do, don't I? So what does that say? G evaluated at negative x is the negative of g evaluated at x. That was this thing here, wasn't it? So is this even or odd?
Odd.
It's odd, isn't it? We eliminated even. We got odd. All right. One more example. Let's say I have, h of x equals x to the 5 plus 1. And I want to find out, is this even or odd? So what do I do to determine that? What I did here. So h of negative x equals negative x to the fifth plus 1. So negative x to the fifth is what? It can be positive or negative.
It stays negative.
Negative x to the fifth plus 1. So h evaluated negative x is negative x to the fifth plus 1. And our original was x to the fifth plus 1. So we ask ourselves a couple of questions. Is h evaluated at negative x equal to h evaluated at x? Is that true or false?
It's false.
Okay. Is h evaluated at negative x equals negative h evaluated at x? True or false? That's what we looked at up here. Here's where we determine even. Here's where we determine odd. So now we're just doing our tests.
It's also false.
Also false. So that says that this equation is neither even nor odd. So it's neither. So we have possibilities of them being even, odd, or neither. Okay. Questions on that at all? Make sure we understand what's going on there.
Could you scroll back up to see like how you determine if it's odd or even? I mean, you showed that for a second.
Yes, here's how we determine even. Here's how we determine odd. Okay, questions on that at all? Okay, let's take a look at our last example, which is looking at something called a piecewise function. And this might be something that's used, for instance, by a phone company. And they might say, you know, the cost of your bill, and I'll let C represent cost, is going to be dependent on the number of minutes, the amount of time that you're using your phone. And we're going to have two different ways we're going to evaluate the cost we're going to charge you. If you use 20 minutes, then we're going to say, we're going to charge, not 20 minutes, $20. We're going to charge you $20 if the amount of time you use is less than or equal to 60 minutes, less than or equal to an hour, but greater than 0 minutes. So if you use from 0 to an hour, we're going to charge you $20, and this might be per month, for instance. Cost you $20 a month. If you don't even use your phone, it's going to cost you $20. If you use 59 minutes on your phone, it's still going to cost you $20. 60 minutes, $20. Okay. But then the phone company might say, you know, if you use over 60 minutes, then we're going to charge you an amount above the 60 minutes here, and we're going to charge you at the rate of 40 cents a minute. 40 cents per minute if you're over 60 minutes. So we're going to charge you the same $20 per month plus the amount of time that you're over 60 minutes, and I'll say that's T minus 60. So T minus 60 would be the amount over 60 minutes. And we're going to charge you at the rate of 40 cents a minute. So this is called a piecewise function because it's divided in this case 2 pieces. If your time 0 to 60 minutes, I'm going to charge you a flat $20. If you use more than 60 minutes, I'm going to charge you the flat $20 plus so much a minute. Okay. Questions on what we did there? So now I'm going to give you an example. So let's say you use your phone for 40 minutes during the month. What's the cost for 40 minutes worth of time? Anybody?
It's less than 60 minutes, so you're just going to get charged the $20 a month.
So we're going to say that's going to cost you 20 a month. Okay, makes sense? We look at the time that's being used and we say, where does it fall? Well, it falls in this time frame here, 0 to 60, so we're going to charge you flat 20. Let's say you use 80 minutes in a month. Now give me a new volunteer that can tell me what that's going to cost. And more importantly, how would I figure out what that cost is? I'm going to be down here, aren't I? Over 60 minutes. 80 minutes is more than 60. So we're saying the formula is $20 for the month plus 40 cents times the amount of time over 60. Well, we're at 80. So 80 minus 60. So we're at $20 plus 0.40 times what, 20? So that's $20 plus, what do I get here? 20
8.
times 8. So the cost is going to be 8.28. So my cost for 80 minutes then becomes $28. Okay, everybody okay on that? Okay, questions? Okay, last concept for today and then we're done. Last concept has to do with the difference quotient. And the difference quotient is used when we're looking at, for instance, say we have some curve, maybe it's a straight line, does that. Here's X, here's Y. And I look at a couple of points and I say I have a point here and I have a point here. And maybe I call this, well, I could label the points. Let's just say this is X and this is X plus H, whatever the difference is. And this is F evaluated at X, that's this. And this is F evaluated at X plus H. Okay, does that make sense? So if we go out here and use X, then we calculate F of X, X plus H, we're up here at F at X plus H. Okay, so the difference quotient says difference being the greater Y value over the lesser Y value. So that's like Y2 minus Y1. So Y2, we might say F at X plus H minus F at X. So that's the vertical difference there. And then I also want the horizontal difference. I'm going to divide by the horizontal difference, which is X plus H minus X, isn't it? That's this distance here. X plus H minus X, which really just says that's H, isn't it? So that says the difference quotient then looks like F at X plus H minus F at X over the value, that shouldn't be H, should it? That should be X. X plus H minus X. So x, negative x, that leaves us just over h, doesn't it? So that says the difference quotient then looks like this. That's what we mean by the difference quotient. Okay, questions on that at all? Now I'm going to give you an actual problem, but that's the concept of difference quotient. Okay, so let's give a function that doesn't look like this. Let's say the function looks like f of x equals negative 2x squared plus x plus 5. That's the equation. So that's going to be a parabola inverted and so forth. So we said, let's then calculate the difference quotient for this equation. And we say, well, then the difference quotient is going to be this. So we evaluate this at x plus h. So when we evaluate this at x plus h, we get what? Negative 2x plus h quantity square plus x plus h plus 5. Okay, so we get this as this value here. That's this. And from that, we're going to subtract f evaluated at x. So we're going to subtract f evaluated at x. Well, that's this. So that's minus 2x squared plus x plus 5. So that's the vertical. And then we'll put that over the horizontal, which was just this xh value. Okay. So far, so good. So now we have to do these multiplies and then combine values. So if we do those multiplies, we get negative 2x squared. I'll just multiply 2 times when I get this x squared, right? Plus 2xh plus h squared. And I multiply that by negative 2. So negative 2x squared minus 4xh minus 2h squared. That's just taking this and squaring it and multiplying that by negative 2. Plus x plus h plus 5. Now I'll distribute this negative through here and I'll get 2x squared minus x minus 5. And then I combine terms. So I've got 2x squared negative, 2x squared positive. Looks like those are going to cancel. And I've got 4xh. Do I have any other xh's? Doesn't look like it. So negative 4xh. And then, so I've got rid of that. And I've got 2 of the h squareds. I guess that's all I have there. Negative 2h squared. That takes care of that. And then I've got a positive x and a negative x. So those are going to cancel. And I have a positive 5 and a negative 5. Those are going to cancel. Then I have this h here. So plus h. And that's all over this h here. So the difference quotient has been reduced to this. But now I see that I can factor out an h, can't I? I have an h all the way through here. So if I factor out that h, we can take that away, take that away, take that away, because we're dividing through by this h here. So that leaves me in the numerator negative 4x, that's this value, and then negative 2h, that's that value. And when I divide this into here, I just get 1, don't I? So plus 1. So I end up then with the difference quotient being negative 4x minus 2h plus 1. And the restriction being that h cannot be 0. We can't be dividing by 0 here, can we? Okay, so that's the difference quotient. It's difference being f evaluated at x plus h minus f evaluated at x and divided by the distance between x plus h and x, which is just the h value. 2 h's in the denominator. Then we put that into whatever equation we're given and subtract and divide by h. Okay. Looks like we are at the end of class for the day. So we've covered P1, P2, P3. We've identified intervals where functions increasing or decreasing or is constant, maximums and minimums, and even and odd functions, piecewise functions, and the difference quotient. So I think we've covered everything on P point, or yeah, 1.3. All right. 5:10, I'm going to stop. I'll stay after class if anybody has questions, but we're done for the day. When am I going to see you next?
Monday.
You next
Mon-
Monday, Professor. Thank you so much.
All right. Thank you.
Thank you.
Bye.
Have a
Bye-bye.
nice day.
Thank you.
Thank you. Have a good day.